Hello, I'm Ha-sung Choi from Ewha Women's University in Seoul, South Korea. The title of our paper introduced in this ICCV poster session is Environment Agnostic Representation for Visual Reinforcement Learning. Deep reinforcement learning is the field that trains agents to solve various tasks, including complex control and video games. Since real world changes dynamically at all times, the ability to generalize an agent against visual variations is indispensable in this field. However, the high-dimensional observation space of visual inputs imposes several challenges in adapting the agents to unseen environments. Hello, I'm Ha-sung Choi. To deal with this issue, we propose a novel generalization method termed Environment Agnostic Reinforcement Learning, EAR, which is a compact framework for domain generalization of the visual deep RL. To be more specific, our method attempts to extract an environment agnostic feature, EAF, and use it to learn the RL policy network. Hello, I'm Ha-sung Choi. To summarize, EAR has the following affirmative assets. First, EAR proposes a novel domain generalization framework designed for visual RL, which segregates the intrinsic property needed for policy learning. EAR is a simple single-stage training method which applies only novel objectives without several training steps. EAR maintains a low model complexity and at the same time produces a superior generalization performance. Hello, I'm Ha-sung Choi from Ewha Women's University. This is our overall framework. EAR separates the environment agnostic feature from the latent representation and use it to learn policies for RL. Through representation learning, we can guarantee that policy training proceeds only with the suitable feature from the observation of an unseen environment. Hello, I'm Ha-sung Choi from Ewha Women's University. Given raw input observations where t and t plus 1 represent the time step, we first apply two different augmentations, A1, A2, and obtain base features ft and ft plus 1, which are the output of the base encoder. Then, vectorization encoder separates EAFs from base features, respectively. Finally, the difference between base feature and EAF is defined as the environment-specific feature, ESF. Then, using the assumption that EAF and ESF must be independent and not related at all, we can impose a feature separation constraint which maximizes the cosine distance between two features as follows. Also, the addition of EAF and ESF should be formed similar to base feature. So we can also impose the mean square error MSE between features to give a reconstruction constraint. We also impose a novel complementary constraint that separated EAFs, which we assume as a newly generated state, is consistent with respect to state shifting. We introduced the episode-aware state shift ESS module, which uses an action vector as a medium to constrain the vectorized vital features of two consecutive frames. First, the action-conditioned prediction, ACP, first predicts EAF at the next frame from the current EAF using the associated action. Then, the state shift constraint is imposed by applying two projection heads and one predictor as shown in this figure. We follow the self-supervised literatures to compute the target feature using the network updated via the exponential moving average. Hello, I'm Ha-sung Choi from Ewha Women's University in Seoul. To validate the capability of the proposed method, we evaluated our algorithm on the DM control shoot dataset. We train agents on original environment and evaluate them under various environmental changes and visual distractors without any reward or prior knowledge about the test environment in order to evaluate the generalization ability. This is the quantitative evaluation of episode return on DM control generalization benchmark, randomized color test. EAR significantly outperforms existing state-of-the-art methods without any test time adaptation or using the additional training stages. Hello, I'm Ha-sung Choi from Ewha Women's University in Seoul, South Korea. The title of our paper introduced in this ICCV poster session is Environment Agnostic Representation for Visual Reinforcement Learning. And this is the quantitative evaluation of episode return on video background test. Due to the nature of the proposed method of feeding environment-agnostic features to the RL algorithm, the trained agent come to be robust against a variety of changing background distractions. More experimental results can be found in our original manuscript. Thank you for listening.